image or audio. And we can do in another way also. The first part of the model will be audio and another part will be text or image. And last way, another combination, like starting part of the model will be an image and outcome will be text or audio. So this kind of models people developed. So the famous things are DALI and Clip. Those two are very famous multimodal language models. So mathematical formulations is very easy, just like a autoregressive language model. Here it is again conditional probability kind of thing. Mean conditional probability of text will depend upon the image and image will depend upon the text. Or same you can use the image and audio, means text will depend upon image and audio, or image will depend upon text and audio. Like that you can change it. Now I will show you that how it actually works in a real scenario. Because when we, for example, I opened one chat GPT. This is a paid version, professional version. So here you can see that the text, with the text we can create the image also. Video facility is not available now. For example, if we say it like, it will create that image also. So I have just written like draw an image for generative AI learning. So it will add something like, okay, this is the way they think that a generative AI learning may be. After that, by adding text, you can change it. For example, if I say that add human in the background. So all those executions from text to image is going on the multimodal language model way. So it will add human in the background. See, they modified the image, added human in the background, like person is learning generative AI. So this is the process of doing things. Other than this, you can do a lot of other things. I'm just giving such examples to generate the curiosity. For example, when you try to write some PPT, generate some PPT, or when you try to some develop some flow diagram, then it requires a lot of means information, creating tables takes a lot of time. But it is too easy with such kind of models. For example, suppose I have a text here. I just copied this text. This text is related to some bear, that is animal living in the polar area. So I will just copy this text here and say that prepare a mermaid diagram for the following text, and then I will add the text. See, it will create the mermaid diagram. See, it has created this mermaid diagram. Now I can easily convert this mermaid diagram into some flow diagram by using like this. Draw.io, you already aware of those things because people use this to generate images or flow diagrams. But suppose you have some text, then it is very easy to generate such diagrams. Just to copy this, I will just say the create diagram, and then I will select the mermaid. Here it is already selected. In the same way, it has generated here. Only things are like we don't have a semicolon at the end, so we can replace it. To just add the semicolon after that, and it will generate the mermaid diagram for us. So this way you can develop your own flow diagram for any given text. Suppose you write and suppose you are preparing some PPT, and for a given text or concept or some news articles, some story or something, you want to explain things, then you can easily explain like this. Okay, so here it is some issue, I think. Okay, I will take a smaller one. Okay, just take this one because maybe I have missed some of the semicolon because text is. So based on that, it can create the mermaid diagram like that. And with the help of, sorry, with the help of ChatGPT or anything, you can just give the text and say them to prepare such kind of diagram. They will understand the text, analyze the text, identify all the information flow, and then prepare like how they will be connected with each other. And based on that, it will prepare the mermaid diagram. Means for mermaid diagram, you have to use some tools so that you can convert that flow into that kind of diagram, and after that you can do a lot of fillings, etc. Now I will show you. This is just for curiosity. I am just giving some examples, and after that now I will give some more demo. This will give some ad. This will help in getting some curiosity. So now the language models, I have gone through the language models. Now the things are like how can we apply those language models in our daily life, or we can achieve something through coding with the help of like such kind of chat GPT, Gemini. It is very easy to ask questions and get anything. Here you can do a lot of other things. For example, suppose you have some research paper and you think that you are not able to understand that research paper. That research paper is in PDF format. Just upload that. For example, if I upload the PDF research paper here and say that I am not able to understand this research paper, give the complete concept of that research paper, it will analyze and give that. And suppose you say that you have two research papers and you want to compare both. You can upload both research papers and write a simple prompt like compare paper 1 and paper 2 and explain that whose research paper's concept is stronger and why. It will explain that out of paper 1 and paper 2, whose concept is stronger and why according to the technical background. And suppose in a research paper you are not able to understand some of the technology, then you can just ask the question that in the attached research paper, explain this concept in more brief or in more detail, or like based on your prerequisite knowledge. For example, suppose you don't know a lot of probabilistic theory, then you can say that explain near to layman terms. They will explain. So this is the different uses of large language models. Means you can even here you can use the text to generate video, but this facility is not available here. Now another thing is like what are the architectures? For example, here I had just introduced to you regarding ChatGPT, that is very famous, and after that there is a Gemini, that is from Google, Llama, that is from Facebook. So what are the things which are working on those things which helps you in getting such kind of responses? So this is very important to understand. So the main thing is architecture. So first part that I said, if you consider just a text-based system, then all such kind of large language model will use the auto-regressive language models. But if you are using multimodal generative AI supported language models, then they will use multimodal models in the background. And what is the architecture? So all such kind of systems are actually based on transformers decoder architecture. So only transformer decoder architecture supports such kind of language models. And what are the components which are working, which helps in achieving such kind of auto-regressive language model? That is called stacked decoder blocks, causal masking, and layered output. So now I will go in little detail, like why transformer decoder architecture help us in generating the auto-regressive language models. So first of all, I will go through the very basics of the transformer. I will try to explain in a very layman terms. So this is a general transformer block architecture that you can find in very famous paper, that attention all you need to know. The first part of the input is positional encoding. So positional encoding is one of the major advantage of all the transformer architecture, because prior to that positional encoding architecture, people were using the sequential information. For example, large LSTM. So in LSTM, RNN, there we were using sequential mode of input text. And some other architectures like CNN, deep neural network, we were using like text is as it is, like when it comes, where it comes, just to use that, like a dot or some number or some object. So we were missing that relation, like how the texts are actually binded with each other. So in that case, the transformer architecture, the major thing is invented here is positional encoding. So in the positional encoding, we use sine and cos based periodic functions to represent the position. For example, if I use the same text like the cat state, then general index position is 0, 1 and 2. But the periodic positions will be little different. So why we are using such kind of periodic system? Why we are not using such kind of index-based system? The answer is, when we use such kind of index-based system, after certain length, you will lose the semantics of the text, because if you see very longer text, then you will find that the first word and a very last word of third or second sentence is not related with each other, because they lose the semantics. Or so to maintain that, we are using such kind of periodicity so that it can repeat and we can manage some context. So that's why such kind of periodic sine cosine based functions are used in the. So this is very important. Another part is self attention. That is also very important. Now, how the self attention helps in getting understanding the auto regressive language model. So the same example, if I say the cat sat on, suppose we say like this, and So the major advantage of autoregressive language model is like it the next word depends upon the previous words. So transformer decoder architecture supports this by adding masked attention model. So in masked attention model, what happens? When we add this word, we can see this word only. When we are at this word, we will see this word and this word. But we cannot see this word and this word. When we are at this word set, then we will see the cat set, but we cannot see the on. Suppose we are here at this word, we can see all the previous words. This way, what happens when we train the system? Then, for example, if you disclose everything before the training, means system is able to see this, then the system will not effectively able to predict the cat. The system will not effectively able to predict the set, because in autoregressive language models, when we use the masked attention to predict the set, it identifies the context like the or cat, the and cat, whether the set fits with the and cat or some other words will better fit. So if you hide this, then system can take the decision. So this is very important. That's why all the large language models, especially Chat GPT or Llama 3, Llama models, generally use the decoder only architecture and autoregressive language model, and this plays a very important role in getting the correct context based text identification. So all those language models, when you generally see that those language models are able to do so many things, then how people train those models? Those models are just trained by using next word predictions. But here the length of next word predictions are too high, like thousands and sometimes some lakhs also. And after that, to get improve the representation, they use the multi-head attention. And after that, the next part is feed forward network layer. Now you will see that say that why we are using feed forward network layer. What is the use? Because we already calculated. Okay. So you already calculated that we are using self attention, layer normalizations, multi-head attention, then we apply some layer normalization also. Now why we are using this feed forward network layer on the top of that, especially in the decoder architecture. So what happened when we calculate the next word, for example, the, cat, sat, after that on. Now in place of on, there may be multiple words like cat, sat, at, in. There may be multiple things possible. So which may be the best possible thing in the according to our complete vocabulary. The feed forward network layer gives the score on those things, and it helps in setting that how to exactly after calculating the attention score will give the finally it will give the context vector score. From that context vector score, you will be able to understand that what is the context. Like the context is the cat set, and according to that, you have to identify like which may be the best fit. So feed forward network helps in that. It will give the score, and based on that, system will learn like how to understand the text. So this is very important. So now the architecture, suppose we take just the encoder layer. So encoder layer and decoder layer, the major difference is at the self attention layer, at the encoder part, we are not using masked attention. We are not using masking. And when we use the decoder part, we use the mask. So a lot of language model which are not autoregressive generally use encoder part of the transformer. So now you understand that what is a large language model, what kind of things we can do, how it is multi-model, how we can use text to generate image, or we can do a lot of things. Next part is like what are the background architecture in the transformer which supports auto-regressive language model which are used by the key language models these days which are available. There are thousands of language model available. They are using different concepts, but these are the most famous. Now we will go through the quantization techniques. So what is quantization? So before understanding the quantization, because it is a famous known technique that we will use quantization, this, that, actually what happens, just to take a very simple example, you will understand that what is the requirement of quantization. Suppose you are developing a simple neural network architecture like this, and then it is connected like here. So here it is 2 nodes, here it is 3 nodes. So to store the weight, what you will do, you will create a matrix 2 by 3 matrix, and this will store the weight of this part. Similarly, another matrix will store the weight of this part. So based on the layer, you will store the weight of those information. So actually what happens when we train the neural network architecture, it learns the weight of those neurons. So those weights of neurons are actually the things that you actually save in the form of model, trained model. So same thing happens with the large language model. So large language model contains a very big transformer architecture. And when you train the large language model, it prepares a huge size matrix in the form of trained model. The problem of such kind of matrices are like, it is not like a 3 by 3 or 4 by 4. It may be like a billion into billion. Such kind of thing will be possible. For example, GPT 4.0 actually contains 1.67 trillion parameters. Now you can assume the size of the matrix. For a simple laptop, suppose someone say that take this 7800 GB size GPT 4.0 model and copy it in your laptop and do anything. It is not possible because it is beyond the capacity of general laptop. So this is the scenario. Now the things are like, suppose you use the same model in your server also, and suppose we are doing some inference through this model to get some output, then for one inference it is okay. But suppose we apply thousands or millions or billions of, for example, now I just put some query. Similarly, I don't know how many people were doing the same kind of things at that time. So it may be millions of requests coming to those kind of models. So every time accessing all the information from such a huge size model actually creates a heavy traffic and heavy resource requirements. So this is not feasible if we store the model directly in this format. So what happens? People store, people apply the concept of quantization. You can always see such kind of things like quantized 13 bit, 12 bit quantized, 8 bit quantized, 16 bit quantized, 32 bit quantized models are there. So you can see that. Now what is quantization, you will be able to understand. So now suppose we are using a large language model, but it is small enough that it stores the entire weight into 3 by 3 matrix. It will store all the weight in the floating point format like here, and how much information is actually taken by each of the floating point number. So there are 9 values and each will use 32 bits, means 8 byte information. So 9 into 32, if you just take the bit, then it will take that amount of information, means that amount of memory requirement. So suppose I quantize that into integer format. Integer format just takes the 8-bit space to store. Then you can understand that what will be the size. It will be just 72 bits. So you can understand the difference. So if this way you can reduce the size, which are billions parameter or trillion parameter model, then you can assume what inferencing speed you will get from the same resource. So this is the basic motivations behind those quantization techniques. Now you will see that, say that, okay, if I convert this, it is in integer format, it is in floating point format, but actually we stored the data in the floating point format. This is the original format in which the weights are stored. So if we convert it into integer, then how the system will work? The system will work like that. After you get some query inference result, it will dequantize that part. And the dequantization will result in very little change in the actual information. For example, if you dequantize that, if the value is 0.14, its quantized part is 15. If you dequantize it, it will be hardly like 4, sorry, it will be 0.45, instead of 5 it may be like 4.9 kind of thing. So this minor changes you can see after dequantization, and it will not affect the result quality, but it will highly improve the inferencing speed, and that's why people use the quantization technique. So again, the quantization, there are lot of different types of quantization. First is static quantization, dynamic quantization, quantization aware training, precision level. Again, you can say that, okay, we will use 8-bit integer, 4-bit integer quantization is also possible, mixed precision, binary quantization, 1 bit. And again, you can do some another variety like weight quantization, activation quantization. So what is activation quantization? That is important because other thing is very simple to understand. Actually what happens, generally when we take the neural network architecture, then this part is the summation part and this part is activation part. So when we pass this like wx plus bias, then we pass those information through some activation part. So at the activation level quantization, they use the quantized value here, but output after the, like suppose you apply the sigmoid, so it may multiply with some number. So after that the value will come and it will be in the floating point format, means, and after that it will convert into the next round or some kind of thing. So this way they manage, means it will not directly round the output. So activation output it manage, and once they get multiple such output, at the final stage for next layer or some other part, they quantize it. So they maintain at some distance, they maintain the floating point information. Post training quantization, stochastic quantization, so many things are possible. So I will just go through the simple basic concepts which are highly used. So dynamic quantization. So suppose we have a 3 by 3 weight matrix. We are assuming that we got a very small weight matrix from the large language model. That is a 32-bit floating point matrix. And it uses 32-bit value for every storage. Now, the first part of this quantization, how we do that quantization. So this is very important. First, we have to identify that what is the minimum value and what is the maximum value. And next, we have to identify that what will be our quantization scale. So suppose we are using 8-bit quantization scale. So 8-bit quantization scale means our value will vary from minus 128. The value will vary from minus 128 to plus 127 because there will be 0 in between. Now another part is scaling. So why scaling is important? Scaling is important because when we convert the number floating point to number, we cannot always consider that this 00 will be 00 for any representation. There may be, for example, here, if you calculate the scale and identify the 0 point, you will find that its 0 point is here. Sorry, this is minus 15. This is the 0 point. This is not actual 0 point for that matrix. This matrix means this matrix is situated at this place somewhere. So when you reverse quantize and you have exact 0 point, then it will not create any issue in future. So we calculate two things. First, scaling, and second is 0 point. So the quantization involves calculation of scale and 0 point to map the floating point value to the integer range, because without scaling and without 0 point, if you just convert it into some integer format, it will reverse conversion is not conversion will not be accurate. So the formula is very simple. So maximum weight minus minimum weight, and what is your range to convert. So range was 8-bit. So positive side was 127 and negative side was minus 128. So this is used here, and this way this is the scale we got. So with this scale we will get the 0 point. So 0 point, so negative point minus max divided by scale. So this is our actual point where the entire matrix coordinate will belong. So with this scale, we can easily convert this matrix into this format. And now, how to convert? The entire formula is very simple. So what was the original weight? What is your scaling? What is 0? So take the upper, that bound, take the, floor means the value, and then minus 15. So what is your 15? 0 point. Because when you take the plus and but your actual negative point is minus 15, so it will be here. So when you calculate, you will get this matrix. So this is your dynamically quantized matrix. Here I have shown that how to calculate S and 0 again. Now what will happen when you get your query inference results? Then you have to collect the actual information from the model, because your calculation inferencing part is done. So then you have to dequantize your output. So this is our actual and this is our quantized integer format. So dequantizations again you will have to calculate S, and that is already calculated. I have just reused it so that we will not miss anything. So dequantizations formula is very simple. For Wij, any element x means ith and jth element, row or column element of matrix will depend upon the scaling factor. What is the quantized value minus your 0 point. So this is, you will, sorry. So this is your result after dequantization. Uh, Fortunately, in this case, calculation was highly accurate, so I didn't face any difference in the quantized and dequantized results. But now here, I have taken another example for static quantization. So in the static quantizations, what happens? Again, same floating point 3 by 3 matrix I have used. We assume that we are getting floating point value like this. Again, we calculated same mean and max. After mean and max, we will get calculate the scaling factor and 0 point. So this is our 0 point. So this 0 point shows that with teams, I think pain is moving here and there. So with this matrix, I think their matrix is situated somewhere at this place. So because their 0 point is positive, so means their 0 again is not this 0. So quantization is again same. So same process we applied to quantize, same formula, everything is same, and we get this matrix. And after that, when we dequantize, again we apply the same formula, we will get this matrix after dequantization. But here you will see some differences. In place of 1.25, we got 1.246, but difference is too less. Minus 3.75, we got minus 3.738. So little differences we got, but it is not so high that it will totally deviate our responses. So now we have to show the what are the key differences, because they are all using the same technique to quantize. Then why it is dynamic and why it is static? So first, check the timing of quantization. So in the case of dynamic, weight are pre-equalized and activations are quantized on the fly during the inference. And in the static, they used some random matrix and some pre-quantizations before the inference. But in dynamics, they quantize at the time of inference during the training. And another is like activation dequantization. So in the dynamic, activations are quantized dynamically based on the input range. And here activations are pre-quantized by using some calibration data. So calibration data concept is like we are using some means we are using some prior work before training with some calibration matrix, and we fix those points. Means at in the static part, the problem is like we cannot change it dynamically during the training or during some, means it will not be effective with some ongoing changes. And performance, because we are doing online changes, so definitely it will be slightly slower. And static, because we calculate everything prior to the training, then it is fast. Model size, so dynamic model size is reduced because we are calculating on the fly. Static means it depends upon like what kind of calibration matrix and what other resources you are using. So it is means it will fluctuate. Accuracy, so dynamic less accurate as the activations are dynamic. Static you will get better accuracy, but some issues in the generalization. But here it will be constant accuracy during the generalization also. But still one thing I can say that this is your original matrix and this is the dequantized matrix. You can see the differences. So due to these differences, definitely it will reduce the performance quality, but not like the cost. Means in the proportion of cost and quality, most of the companies and means research organizations generally prefer the quantized versions because they cannot spend so much money on resources. So there are some another approach for quantizations like post-training quantizations, quantization-aware training, low-rank quantization, mixed precision quantization, adaptive quantization. So these are some techniques. So post-training quantizations, you can see that involves the model after it has been trained. Means once you train the model, you can apply the quantization. Generally, it uses 32-bit floating point algorithm, means notation. And the key algorithms are like uniform quantizations and non-uniform quantizations. Again, they uniformly quantize all weights or non-uniformly quantize all weights. Another part is like quantization aware training. So quantization aware training simulates the low precision during the training by including the quantization process in the forward pass of the network. This is very important. In the back propagation, it will not apply any quantization. Take quantization strategy here. For example, when we train the network, so what we do, suppose we have a network like this. So when we train such kind of network, we do a forward pass for and then backward pass. So backward pass uses the gradient based method, and due to the backward pass we update the weight of those neurons. So during the backward pass, the quantization aware training leave the floating point numbers as it is because they believe that it may affect the quality of the means final quantized model. Only at the time of forward pass. So forward pass we generally use such kind of operations like WX plus bias and then apply some activations. So this forward pass works like a means they apply the quantizations means floating point to integer conversions kind of thing. But at the backward pass they are not taking this, where we take the derivative with respect to the total loss. So this is the main funda of all the algorithm which comes under this type of quantization. So key algorithms are like straight thought estimator. So it used to approximate the gradient non-differentiable quantization function during the backpropagation. So it assumes that loss by dx is nearly means near to 1, and for small gradients it ignores the quantization step. So what happens, as I said, during the backpropagation most of the training aware quantizations apply the quantization do not apply the quantization, but here it applies some relaxations. Like for small gradients, it ignores the quantization step. So again, there is another strategy, loss functions modifications. So they modify the loss functions to ensure the minimum precision loss. So these are some strategies. Another are like LLM quantizations, low rank quantizations. So it reduces the dimensionality and weight matrices before the quantization by using the low rank matrices. Actually, I will in the later part of the tutorial, I will explain the low rank adaptation techniques for fine tuning. There I will explain it more detail. So I am leaving it. And another is like mixed precision quantization. So as you know that mixed precision means it uses the multiple precision format where they find that some information is very important. They use higher precision bits some information moderate importance, low, medium precision bit, and some information which is not very useful, low precision bit. So this with these combinations they apply the mixed precision quantizations. And then there are adaptive quantizations. They dynamically adjust the bit width of the quantization based on the data distributions or importance of the different layers. Because what happens when we use the large language models, we use multiple decoder architectures having different components in the architecture. As I said, it uses attention layer, layer normalization, then feed forward layer. So based on the importance of those layers and a particular kind of like reunion or other things, they decide the quantization strategy. So, but before going into the fine tuning, I am thinking to go through some of the coding, because a lot of theory I think will result in boring tutorial. So I will go through some of the coding and hands-on session. I will try to explain that how we can use those things. So first I will explain how to use the different types of language models. For ChatGPT and Gemini, we can use it for directly online training and test. Online means use. You can directly post the query at their browser, their app. Another version is also possible. If you to take the paid version, they will give some API key. With that API key, you can directly use those models in your code. So these API keys are highly very costly. So there are some sites which provides the free API keys for personal use, not for commercial use. So for any kind of training or code or anything, you can do this. So for example, Grok is one of the such kind of providers. So here you can see that what are the things inside the Grok. So what are the products? Means what kind of models it supports. So here you can see that pricing if you want the enterprise case, but if you just go with free API key like I selected, it will say to login. Yeah, it login. So earlier I had requested for a API key. So I have this API key. I will show the example with this API key only. You can create new API key also. And with this API key, you can, now I will show another thing also. So here there are models. So this is very important. So that API key will work on these many models. So here you can see what are the different models they provide. They provide Gamma model. Gamma model is developed by Google. This is the size. They provide Llama. Llama two types of models they provide at a free of cost through Google Grok. Through Grok Cloud. Llama 3.1 all type of model and Llama 3.2 also. So Llama 3.2 is actually multi-model kind of models. So here you can see that Llama 3.2, 1 billion, 3 billion, 11 billion they provide. And from these models, you can do some multi-model coding. So now how to write the code? For that, I will suggest you to go through the documentations. You can select one model. They will give some example code. But here I will demonstrate so that with all those information like how large language models are working, what are the techniques behind that. You can do this also. So here you have to install the group. So this is very simple. Just do the pip install group. The installation command is also available here. How to install in the tutorials and documentation part if you go through it. So once you install the group, you have to import the group and then you have to write this part. This is very important. So in this part, you have to add this API key that you actually get, that I actually get here. So I copied this API key here. And after that, we can do anything. For example, now I want to use this for a simple question answering. So another thing that you have to do that, after that, you have to identify that what will be your context, in which context you want to question and means you want some information. For example, I have personally supplied one document. So that document is nothing. I just copied the polar bear related information from Wikipedia, 5-6 sentences and pasted here. So this is my context and your input will be like what kind of question you want. So question, what kind of question I want, I say that how polar bear's body looks. And I am also giving hint like I want answer which should satisfy this constraint. So what is our constraint? Like the polar bear is a large bear native to Arctic and nearby areas. So I want the polar bear information, not like polar bear how they are living in zoo or some similar kind of setup, artificial setup. Like I want the polar bear information with this. So I am providing this one context information. Why I am giving more impression on this context information? Because this is a single context information I am giving to this prompt, like how polar bear's body looks. So that's why it is called one shot rag. So this is rag, retrieval. So this rag is one shot rag because one context information is given to this question. Another thing is like we have given the complete document from which we want the answer. So this is like a comprehensive question answering system. So we said that we have this limited information about polar bear. I want this question of this information. Apply your understanding and give the answer in this context. Now after that, this is the part like how to set your prompt. So based on that you can set any prompt. Now after that you have to fix this part. This is very important. So in this part you have to apply this chat completion. Means chat completion part actually calls the model. So which model it should call? So model name is llama 3.1 8 billion parameter instant model. So I want the answer from this, and the content that should be used here is input. So input contains this context and plus this document. You can see that this is a concatenation. So string, three strings are there. First string is question, second is context, and third string is data. That is like we want the system to work like a comprehensive question answering. So after that generate the answer. So chat compilations will take the call this model, send this information to Grok server, get the information and store the information in the chat compilation. And from that chat compilation we can collect the answer and we can show it. So here if I run, you can see that within 3 seconds it gives the answer. So here this you can understand that how the context works. Based on the provided information, a polar bear's body is characterized by the following features: large body, long snouts, small rounded ears, shaggy hair. They gives a different kind of paws and claws, and then short tail. So all the information that they had given about the polar bear, like how they will fit according to the Arctic environment. So you can see that how this kind of context assignment works. Like you are getting the exact answer. Even you will find that a lot of information is not available in the your comprehension, but they are able to collect those things and give those things, and it gives the summary also. So this is the way. Now if I remove this part and again run this, see what will happen. uh, some something is some answers are different, some points are different. They say large body, and but there they have mentioned everything according to like why it fit in the Arctic architecture. Now you can do one more thing: remove this data and remove this part, this document also. Now just ask the question. So this is like a zero shot question answering from the model. We are not giving any context or any reference, just asking the questions from that. See what answers it gives. See, this is different. So this is a generalized answer. So you have seen the differences. By changing the context, the answer will change. By adding the context, answer will bias towards that context. So such kind of things are possible. So this is one. Another thing that I will show you. Suppose you want to generate the knowledge graph, and you have a same story of beer. Like beer is like this, that so many informations are there, and you want to get the knowledge graph triplet. So what happens when we have a knowledge graph triplet? So knowledge graph triplet contains three things. First is entity, second is relation, and third is another entity. Means how two entities are, static entities are related through some well-defined relations. So if you have such kind of triplet and related information, you can easily generate knowledge graph for any documents. So here you can see that I have used the beer related information that I copied from Wikipedia. 7 sentences I copied just to keep the system simple during the explanation. So, so our task is give the knowledge graph triplets for the following text. So what is following text? Following text is our document. So what is document? So this is document. Yeah, so this is document. Based on this document, generate the knowledge graph triplet. So for any text, for any book, for any PDF, if you want to generate the knowledge graph with the help of LLM, it is too easy these days. But things are like it should be, the document should be on public domain. It should not be like a personalized kind of document. For example, suppose you have a very personalized kind of text which is not available anywhere else, then what will happen? Generally, all large language models are trained on next token predictions. that is auto-regressive language model that I said earlier. So what happened? Suppose the training data doesn't contain such kind of information from any sources, then it will be tough for large language models to identify such relations or to work on that environment. That's why we are going towards the fine tuning process. Means we fine tune and add extra knowledge to the large language model. So in the later session I will explain like how we can do this kind of fine tuning. Now I will just explain like with this text how we can generate the knowledge graph triplet. So the first part is very simple. You can import the group, and after that you have to call this client ID. That ID I got here, the same ID I called here. And another thing, for example, here I pasted the document manually. You can collect this information through some file also. Take some file path, read that file, store that file into a string, and then pass the document equal to that string. After that chat completion, for that you have to format the message like the grok system understand, like what is the role. So your role is user. You are an user that who have a free API key, and for this input you want the LLM output, and your model is llama 3.18 billion parameter instant model. You can select any other model based on your choice. These are the models. So it is up to you like what you want. But you have to give the correct name, otherwise system will not work. Means any spelling mistake or any case sensitivity related mistake happens in giving the model name, system will not work. So I have tested in different also models like model llama 3.1 70 billion. So different models I have tested, it is working. And once you get call this function and provide the output to the system will display the answer. So for example, when I run this code, it shows like this. So here you can see how the system is generated. So what it identifies, first it identifies what are the entities. So entities are deer, caniforum, dog like, canino, carnivorous, varans, northern hemisphere, southern hemisphere, North America, South America. So these are kind of things they have found as entities. These are relations, and based on those entities and relations, they have prepared the knowledge graph triplet. Like deers classified as family. I'm not able to read what is written. You are your today. Deers classified as caniform. Family reside is a member of. So this way it connected. Deers resides in northern hemisphere. Deers partially resides in southern hemisphere. So it collected all information and prepared this knowledge graph triplets. It identified what are the entities and relations. So just feeding those entity and relations into any of the software. For example, either put those entities or relations in like I had I did earlier in such way also. Okay. So what I did, I just copied such kind of things, I mean some different such things, and use the network X library and prepare the graph. So it is working. See. So this way it can create the graph. So this is a network X. You can do something better like Neo4j. Neo4j is a better package for this. Just to provide all those outputs that is generated by knowledge graph triplet. It will automatically create a very beautiful means, an interactive graph. So these are the all important things. So another thing that I will say that this is one way to use uh, large language model. Means you can use it at free of cost and no need of very good hardware, because even I am running in my laptop. All the inferencing and running things are going on the Grok Cloud server. There is another way that is called Olama. So these days Olama provides these many models: Llama 3.3, Phi 3, Mistral, Gamma 2, and a lot of models they are providing. But this is like you have to download the model and keep those models into your system, and from there that system you have to run, but it will take a lot of time. For example, uh, I did that. So this is a basic RAG. So in this, for this basic RAG I have used the Olama model. So in the case of Olama model, I have used the quantum mechanics related information that again I copied from Wikipedia, some of the uh, starting 6-7 text, and then use the Chrome DB. So another thing is like the concept of Chrome DB is coming, because what happened when we try to identify something which are very much, for example, when we try to define the context for RAG, then directly searching everything from string is a highly time taking. That's why they people these days are using Chrome DB that stores the entire information in the bit format, and it can easily give you the matching bits in output faster than the traditional string search. So we are using Chrome DB client, and then we just put one question. So our question is, what are the key benefits of using quantum mechanics over classical physics? So this is our question. But before that, we have to create the database for the above. This is our information. For this information, we have to create the database. We have to store all the information like with the name of docs, and then after this, we have to create the embedding. For example, I hope that you know the concept of embedding. What is embedding? So if not, then I will explain details. I will use just this place to store, explain. Okay. So suppose I say the text, the cat sat. So what happens? We use multiple different things to generate the embedding. You are already aware of word to wait. Then there is a glove. But these days people are using BERT or some higher language models related embedding. So when we provide the text, it will generate a vector for each of those words, each of such kind of words, in the form of floating point number. So those are called embedding. So here also the embedding is like that. So here I have used the MX by embedding large. This is actually BERT based embedding which uses BERT large. And based on that, we have created the embedding and we stored the embedding in of all the contents of this document. So when we get the text, like what are the key benefits of using quantum mechanics over classical physics, we just we will just embed this part also, and then we will just identify the context by searching the similar things by using this prompt. And once we got this, we use this prompt output answer. We will say that using this data like this prompt and respond to this prompt, just give the answers. So llama.generate will call the actual model that I have used here. So with the help of Olama, we have called the model Llama 3. So it is not Llama 3.1, it is older Llama 3. So based on that, it will try to generate the response, and we will get the final answer. So this is one another way to of doing the same thing. But the things are like in this laptop, it is not possible to run because the Llama 3, even for Llama 3, the size of the model is 30 GB. And here our RAM is just 16 GB, and we are using Teams micro MS Team. We have MS Team working. This ID is working. A lot of things are already utilizing memory. So if I run, then everything will hang. But if you just close everything, you can run it, and in 4-5 minutes you will get the answer. But in Grok, you can get the answer quickly because all the inferencing and everything will happen in their server. Similarly, you can use the Hugging Face library to do the same. So this is the first part of the presentation. So let me know if you have any question. Am I audible? Hello.
Hello, am I audible?
Yes, yes.
Sir, I think one of the audience has raised hand.
Okay, okay.
Jyoti ma'am, you are allowed for mic.
Good morning, sir.
Good morning.
Sir, I just wanted to understand what is the difference between just calling the API and fine tuning the LLM.
Okay, okay. Fine. Actually, calling the API, when we call this API, like Grok, we are calling the model which they actually fine tune and store it. So fine tuning means, okay, the fine tuning means calling API and fine tuning both are different things. Fine tuning is required. Suppose you have developed your own personalized text. Suppose you have means you are doing some banking business and you have developed some of your means strategy plans which are very internal to you and private to you, and it is not possible that all such rules are very much common in public domain. Means you have developed your personalized rules. So in that case, if you ask the questions regarding your bank related operations, then large language model will respond uh, in a very generalized way. So it may not fulfill like your requirement. So to fulfill your requirement, you have to fine tune the large language model according to the what new things that you have added, so that when you try to ask the questions regarding your requirements, your rules and regulations that you had established for your bank or banking organization, then after fine tuning only they will be able to address those information. So fine tuning means adding all the extra missing information to the large language models. There are multiple ways to do that fine tuning. So in the next part, I will cover that fine tuning portion. And using means API key is like we don't have, suppose we don't have very high hardware resources. For example, now I'm using this for this presentation. I'm using 16 GB RAM laptop. So I know that know the limitations of this hardware. I cannot download the model and run it in hours through our laptop. But I can easily show a lot of running examples by using the API key, and those APIs are not fine tuned. They are doing fine tuning, they are using quantization also, but to enhance the speed of the model, inferencing speed of the model, not for our personal content. So that's why both are different things. But some services, for example, if you are using the paid member, suppose you are a paid member, then you can do some collaboration with that organization and say that we are doing such different type of means running such different type of organizations having different rules, regulations, and other information. So use those things and fine tune your model so that we can get the correct answers, and it should not be visible to any other client. Means it should be your private. So that way they will make a copy of their model even in online version and fine tune that model according to your requirements.
Okay, thank you, sir.
Thank you so much, sir. Any more queries from participant side? Please raise your hands. Sir, one more question is there from Dr. Kavita Pandey. Sir, in which applications where we can use LLM models? Could you please elaborate?
Yeah, these days without LLM, I think
Yeah, nothing is,
it is
yes.
very tough to do any research work. I am showing you a very different example. Suppose you are using time series forecasting. So in traditional, what people do in the time series forecasting, they just take the data and apply some algorithm, LSTM based algorithm, transformer based algorithm, and do the time series forecasting. Suppose we developed a weather forecasting model like that, based on the past history, 4 5 years history, it is able to predict the weather. But suppose what happens, suddenly some volcanic eruptions happen at European region, and then you will find that your all forecasting is wrong because it has impacted the weather for which your model was not ready. So in that case, these days people are using LLM added features with the time series forecasting or the forecasting models. Because what happens, all those large language models are fully aware because in the training material they had given the proper information about all such kind of past weather changes, like how the volcanic eruptions at European regions had affected the entire world's weather, how what kind of changes it has made. So when you apply your time series forecasting with LLM generated features and constants, it will automatically correct your results and your output will be correct even if you are forecasting in the scenario for which your data doesn't have such knowledge. But LLM related features will correct that information. So this is the difference. That's why in every area people are using now started using LLM. Not just a question answering or summarization, style transfer, everywhere. Even in data science without LLM, I think you may not be able to get very good accuracy. Maybe if your data is replicating your future thing, you can get some accuracy. But if you want to capture the realistic things, like a human way of working, without LLM, it is very tough to do anything.
Yes, sir. Thank you, sir. Sir, one more query is there from Ms. Aarti Goel. Can you share any example of using LLM for medical data?
Uh, Medical data, right now I don't have any such example. But what happens, for example, I had shown some question answering regarding beer and some examples. So suppose if you replace with the text that I have used for beer and then for quantum physics also. So if you replace those texts with your medical transcript and ask the questions, then all the LLMs which have used the background medical data in their training can answer the questions like a doctor can answer, because that GPT-3, GPT-4 and GPT, even GPT-3 also have passed the medical examination of USA. Means due to some security reasons we cannot apply those things, but safety reasons we cannot apply, but you will find that outcome will be better than a doctor can answer in several scenarios. So this way you can develop a lot of things. Just the important thing is like you have to validate those results.
Yes, sir. Thank you, sir. I think we can have more question in the next session, because
Okay,
we have sir's next session at 2 p.m.
okay,
Thank you
okay.
so much, sir, for sharing your knowledge and expertise. Your expertise has truly opened up new perspective for all of us, and we will look forward to gain your knowledge in your upcoming session at 2 p.m. Thank you, sir.
Okay,
Thank you
thanks.
so much.
Thank you, sir. We
Yeah,
learned a lot, especially at coding part. Thank you so
yeah,
much
yeah.
for
We will.
accepting
I
our
will share all
invitation.
those codings, etc.
Thank you so much, sir.
Thanks.
Now we will proceed for the session 2 of day 1, Generative AI in Healthcare Opportunities and Challenges. It gives me immense pleasure to extend a warm welcome to Dr. Swati Agarwal, Associate Professor, Molde University College, Norway, for this session. Dr. Agarwal is a professor in artificial intelligence and the leader of AI research group at Molde University College, Norway. Prior to this, she was a Marie Curie postdoctoral fellow at Norwegian University of Science and Technology, Norway, where she worked on EU-funded project that focused on developing AI models for detecting developmental delays in infants. Before that, she served as assistant professor in computer science and engineering department at Netaji Subhash University of Technology, New Delhi. Her research interests include brain-computer interfaces, artificial intelligence, explainable AI, and exploring their applications in healthcare. We truly honored to have you with us, ma'am, for this session. Over to you, ma'am. Your screen is visible, ma'am.
Is it visible?
Yes, ma'am. It is visible properly and you are audible too. Thank you, ma'am.
Yeah. Okay, thank you very, very much. And good morning, everyone. And thank you for the nice introduction. I'm Swati, and I am a professor of AI at Høgskole i Molde, Norway. And today I will be talking about generative AI in healthcare, opportunities and challenges. So before I start with my presentation, I am so excited to be speaking with all of you today. So let me start by sharing a little bit about myself. I was born and brought up in Delhi, uh, Delhi, which is a city of chaos, charm, and chart. All these years, I have been living in the NCR region, except for my last 3.5 years when life took me to Norway, a place which is quite literally the opposite, polar opposite of Delhi. If I talk about weather, in Delhi we complain about Dilli ki garmi and sardi, but trust me, Norway's extreme weathers take you to the whole new level. So in Delhi, we shuttle between cotton kurtas and light sweaters. In Norway, it's all about shuffling between jackets, light ones, heavy ones, and extra heavy ones. One of the things that I miss most about Delhi, and I'm sure many of you will relate, is the wedding season. the joy of dressing up, eating unlimited golgappas, dancing, everything is just so crazy. Here in Norway, if I talk about the wedding season, it's more about quiet dinners and polite conversations, which is lovely. But where is the dole? So today, as I talk to my Indian audience online, I thought, why not start with something close to my heart, weddings? Maybe through this talk, I can relive some of the wedding enthusiasm with all of you. After all, what better way to connect than over something we all love? Good clothes, good food, and great memories. So let's take a hypothetical case. There is a Shadi bot, and this Shadi bot is the AI planner for the perfect Indian wedding. In the bustling city of Delhi, a grand Indian wedding has been planned. Just a moment, I don't know. Am I visible, audible? Because there was some
Yes,
call
ma'am,
from
you
the
are audible.
organizer.
You are audible.
Okay. Is my screen proper? You
Yes,
see,
your screen is properly visible, ma'am.
and okay, yes.
I think someone has shared something in the chat window, but you are properly visible and audible.
All right. Because I don't get to see the chat as of now. I just
Yes,
see
ma'am.
my
Yes, ma'am. No, no problem, ma'am.
right. So we were talking about that, let's say some grand Indian fat wedding is being planned in lavish farmhouse near Chhatarpur. And the bride's family, of course, is overwhelmed with all the arrangements. So they decided to hire some AI wedding planner. Everybody's talking about AI, so we have now this AI wedding planner. And then this planner says that I can handle any kind of the wedding chaos. So the first chaos is that the bride's father, Mr. Sharma, said, we have over 500 guests coming from all over India. And I keep forgetting who has RSVP'd. Can you help track me this? Of course, Shadibot said. Why not? I can create a system to manage your guest list, send reminders, and even notify you of special requests like Jan meals or some allergies, food allergies. Now you have to tell me of the different capabilities that this Shadi bot has for managing the guests. In what type, how can you map this? Whether this functionality of managing the guest list would be categorized as something as AI, machine learning, deep learning, or Gen AI. Because this is the third day of the workshop, and I have been told that a lot of you already have gained a lot of knowledge about different techniques. So I'm sure you would be able to do that. Just keep it in your head for now. Um, then the bride's mother, she was very much concerned about planning the food. She asked anxiously this Shadi bot and said that, how much food should we prepare? I don't want to go it waste or fall short. Um, Shadi bot said confidently, I can use my capabilities to analyze the data from previous Delhi weddings and predict exactly how much food you will need based on your guest count and menu choices. So here also you have to find out whether it would be AI, machine learning, deep learning, or Gen AI. And then there is the cousins group. They came running with the video of their dance preparation for the Sangeet and said, can you tell me if my steps match the choreography of Kala Chashma? And then Shadibot replied, of course I can. I will use my algorithms to analyze your dance video frame by frame and compare it with original choreography to give you the feedback. And finally, Bride also had some request. She came to this bot and said, I want my wedding vows to be unique and heartfelt, something that will make the ceremony unique. So Shadibot said, smiled, this is where my skills shine. I can create personalized wedding vows. I can be very creative and I can generate ideas based on your love story. So here is the small activities for all the participants. Can you match each of these 4 tasks with AI, ML, DL, and Gen AI? The 4 tasks being managing the guest lists, predicting the food quantities, analyzing the dance moves, and creating unique wedding vows. So on my screen, you can see that there is a Menti code. No login is required. So you can just go to this menti.com, put in this code of 8 numbers that you can see on my screen, and I'll just show you the results. Can you see this?
Yes,
You just
ma'am,
have
your
to,
screen is visible.
can you, all the participants online, can you please go to this Menti and use this code, the 8-number code? Okay. Are we having just 5 participants?
Uh, Participants, I think all are just doing it, ma'am.
Yeah.
Participants, please participate and use the code to answer the question. We have 17 responses till now only.
You don't have to create the account. It is just the code that you have to enter. And you can do that with your smartphones or your laptops.
don't answer on chat, just go to the website and enter the code. Then you will enter in the
Yeah,
quiz. Yeah.
and it then it is very interesting
Ma'am,
to see how you're
actually
perceiving.
people are doing on chat, giving answer on chat. That's why
Yeah,
I
I
asked.
think it would be very interesting to see the live polls, right?
Yes, ma'am.
Well, I understand that this workshop is about Gen AI, but if you're talking about the different tasks that I just told, maybe you just try to rethink your answers here for managing guests. All right. So majority of people think that it is Gen AI for managing the guests. We will shortly see the answers. Let's move on to the next. Okay, people are still responding. But still, I think the majority thinks that it is Gen AI. Well, the correct answer is AI, and I'll shortly speak about why. Now, the next one. What about planning food, wherein we don't want any food to be wasted, neither we want it to fall short. And the bot said that he can look on the previous wedding data, Delhi wedding data, and plan ahead how much food is required. Interesting. All right, people are thinking that it is ML, and the correct answer is, of course, machine learning. And what about the dance practice? When the robot said that I can analyze frame by frame and can tell you where you are faltering. Okay. All right. So here people think that it is deep learning. And let's see the correct answer. And of course, it is deep learning. And under what category it would be categorized if you want to have some creative wedding vows to be written based on their love story? Of course, it has to be Gen AI. All right. Okay, going back to my PPT. Is my PPT visible?
Yes, ma'am, it is visible.
All right. So going back to the 4 activities that I just discussed with each one of you, the fundamental capabilities of AI, which they were used to manage the guest list, basically AI that focusing that focuses on automating repetitive tasks can very well automate the basic manual tasks like organizing data, sending reminders. For the second activity, which was about predicting the food quantities, which required analyzing data from similar weddings to identify patterns, for example, guest count, food consumption. So, machine learning specializes in finding patterns in historical data and making predictions based on them. So, in this case of planning food, machine learning algorithms would use input data like guest count, menu choices to predict the optimal amount of food needed so as to reduce the waste or shortages. If I talk about analyzing the dance moves from a video, that would involve processing complex visual data, such as identifying body movements and comparing them to some reference choreography. So, deep learning is the one that excels in tasks like image and video recognition because it uses neural networks to understand intricate patterns in visual inputs. So for this task of dance practice, algorithms would analyze each frame of the video to assess accuracy and alignment with the choreography. Uh, for if I talk about writing unique wedding vows, that requires creativity and generating entirely new content based on inputs like their own love story or preferences. So this is a task which is a perfect example of Gen AI's ability to produce personalized and meaningful outputs. Um, I just wanted to have this short discussion about AI, ML, DL, and Gen AI because we first of all need to understand that how are these four terms related to each other. So here AI acts as an umbrella term, an overarching discipline where ML focuses on learning from data. So machine learning is a subset of AI where machines improve their performance by analyzing large amounts of data. So you need some historical data in the cases wherein you need to make some predictions. Deep learning uses artificial neural networks that mimic the human brain to solve complex problems. And the buzzword, Gen AI, builds upon these foundations to create content, making it a creative extension of traditional AI methods. Um, Having said that, let's take a look at how AI, machine learning, deep learning, and Gen AI show up in our everyday lives. So, virtual assistants like Alexa. Uh, so they are your daily basis helpers. Alexa, Siri. They manage tasks like setting reminders, playing music, ordering groceries. So, this is the category wherein we would say AI, virtual assistants. Machine learning is for tasks like filtering out the spam emails. It learns from the patterns in the emails to decide whether it's a spam or not. And the feature that you might be very commonly using your face to activate your phone. So it is a deep learning power for face recognition technology that is being used, like unlocking your phone, tagging people in photos. But of course, it's not perfect. It might confuse you with your sibling. And Gen AI that everybody knows, it takes creativity to the next level. For example, imagine Shakespeare's writing memes about pizzas. So whether it's creating art, texts, or memes, Gen AI can generate content that's both entertaining and impressive. So my today's talk is centered on Gen AI. So Gen AI identifies the patterns in existing data to produce original content such as text, images, sounds, animations, and have impacted many, many industries. So if I talk about the Gen AI models, these models focus on creating the new data from existing patterns, while large language models are subset of these models, which are designed explicitly for language-related tasks. So LLMs such as OpenAI's GPT series and Meta's Llamas are trained on vast data. They can fast track tasks like text generation, summarization, and translation. If I talk about the task-specific Gen AI models, these are designed for particular tasks like image synthesis, style transfer, or data augmentation. So I will not go into the details because I have been told that all these models and their mathematical formulations have already been discussed in the previous talks. So a quick summary, a quick recap of things that have already been discussed with everyone. Um, so GANs use generator and discriminator network to learn from existing data and generate new high quality data specific to the task. These GANs are widely used in image generation, video creation. If I talk about the diffusion models, these progressively remove noise from random input until a clear output is generated. These models are particularly effective for generating high quality images and are widely used in industries where visual precision is essential, like fashion or design. Variational autoencoders. These are the generative models that encode input data into lower dimensional space and then decode it back, allowing for generation of new data. So these VAEs are commonly used in image generation and for tasks like data compression. Flow models allow for exact computation of data likelihood and are invertible, making them useful for tasks that require complex data transformations. These models generate high quality images and data by learning input and output distribution transformations. So we are not going to talk about in detail about their working. What we are going to discuss today is how and in what ways Gen AI can be used in healthcare. So unlike the task-specific models, this general AI can be applied to domains like text, image, and video generation without major alterations. So we have this GPT series, which is an example of Gen AI model, that focuses on text generation. Llamas, it's the Meta's large language model designed for various language-related tasks. Gemini, which is again the cutting-edge Gen AI model for advanced language understanding and creation. So how this Gen AI model work? So these models learn by learning patterns and features from vast data sets. So during training, these models identify the relationships between inputs and outputs, allowing them to generate new data that closely resembles the original data set. So we have the training phase and the generation phase. Because of its high potential, Gen AI is transforming industries by automating complex processes. Uh, so, for example, in healthcare, it is driving breakthroughs in drug discovery and patient care. And that's why it is simplifying and accelerating drug development. In automotive industries, Helm AI that employs Gen AI to create realistic multi-sensor data for autonomous vehicle simulations. So they're using this technology to simulate real-world testing by generating diverse scenarios that enhances safety and bridges the gap between simulation and real-world testing. Likewise, entertainment is another industry. So as you can see on the screen, I have put a screenshot of OSIS Technologies. These use Gen AI to stream VR content creation by automating the generation of 3D assets and immersive environments. So the potential of Gen AI across many, many industries is immense. So today we will be discussing and focusing on the healthcare. And nothing could be a better pictorial description of how Gen AI is impacting the healthcare than this graph. As you can see in this graph, this shows the time range from 23 to 34, the 10-year period that we have. So the prediction is the global generative AI in healthcare market size is calculated at USD 1.9 billion in 24, which is this year, and is projected to surpass USD 39.7 billion by 2034, growing at the annual growth rate of 35% from 24 to 34. This graph represents the immersive annual growth rate of 35% over the next decade, showcasing the increasing adoption and potential of Gen AI to transform healthcare through innovations in diagnostic, personalized medicines, drug discovery, and patient care. So, this is a good combination of Gen AI and healthcare, not only for the industries, for researchers like us as well, because there are so many open challenges, so many open problems that we can take to solve. And in terms of the money investment and the kind of the investment that you see in the graph, this clearly depicts how much potential this combination has. So now I will talk about how Gen AI is revolutionizing healthcare through advanced algorithms and data analysis by giving you some of the prominent transformative use cases. So the first use case that I want to discuss with you is medical image analysis. So I have tried to compile the most talked about. Of course, there are many, many other articles as well, but I have put the screenshot of the most interesting and intriguing topics that I came across. You can click a picture of it if you want to read more about these articles. Um, so, very interesting use cases that this Northwestern Medicine, one of their exciting projects is that they are using multimodal generative AI model that analyzes the X-ray images and generate reports. Now, this system has been used by 50 radiologists, and they have reported the boost in productivity by 40%, which allows them to focus more on the patient care. So they are using Gen AI to create the reports for X-ray images. They're also this Northwestern Medicine. They're also exploring the creation of digital twin for their hospital system, wherein a comprehensive model that would combine the data from sensors, lab tests, would be used to predict patient outcomes and would design personalized care strategies. You can imagine that with just 3% of the healthcare data which is currently utilized, Gen AI holds immense potential to unlock insights from untapped information. Another news that I want to share, another news item that I want to share with you is about the Microsoft, and they have partnered with Mass General Brigham and University of Wisconsin Medicine for developing the advanced multimodal AI foundation models. And what these models will do, They will automate the tasks like image analysis, organ segmentation, and abnormality detection. Now, these models are built on Microsoft's secure Azure AI platform, and this would help to streamline the workflows, improving the diagnostic accuracy, and of course, reducing the physician's burnout. So, Gen AI is helping bridge the gap between the innovation and the real world clinical applications. The ultimate goal for this task is to accelerate advancements in medical imaging and improve the outcomes for patients. So, to summarize how it is helping the clinicians or the patients. So, Gen AI is playing a very important role in enhancing the analysis of medical images like X rays, MRIs, and CT scans. They help the radiologist in diagnosing diseases more accurately and quickly. So, I have a short demonstration wherein I will showcase how Google's Vertex AI Studio will be used to create the reports for medical images later on during the at the end of the presentation. Um, so Gen AI can generate high quality medical images which addresses the scarcity of diverse and extensive data sets. Because we don't have always the right number of data or the right size of the data, because it is one thing is that the medical data is sensitive. If you have to generate your own data, you can use Gen AI to generate synthetic data. So this generation of synthetic data mitigates the problem of overfitting, and also it helps to populate a scarce data set to render accurate diagnosis across different patient groups. Also, this Gen AI can be used to analyze EHRs, electronic health records, medical records, medical images. They can use different types of data, text, image, videos, and can integrate to give you a comprehensive summary of the report. Of course, Gen AI can be used to generate report, but it is very important to note that the legislation requires human certified doctor to make a final diagnosis. So Gen AI, of course, is a powerful tool for doctors, but it is ultimately the physician that should make the final conclusion. We will talk later about this, more about this later. Another task, another use case for Gen AI is drug discovery and development. So again, you can see that there I have put the screenshots of the latest and the very interesting developments in this. So the pharmaceutical industry is also reaping the benefits of AI in healthcare. And how does Gen AI can help? They accelerate drug discovery by generating new molecular structures, repurposing existing drugs, or enhancing drug formulations. By predicting the drug interactions, that helps in the design of safer and more effective drug regimes, optimizing the clinical trials. So, by accurately predicting the patient responses, determining optimal dosages, so these are the different ways in which Gen AI is being used. So, this Gen AI advancement not only streamlines the drug development, but also enhances the safety and efficacy of medications available to the patients. So in the generic way, if we have to sum up how this Gen AI is impacting drug discovery and development, so I would like to give an example of Google Mind's AlphaFold platform. So this platform utilizes AI to predict the 3D structures and interactions of proteins from amino acids and accelerates the identification of multiple drug targets, uh, which is an important breakthrough in solving fundamental biomedical challenges. And if you remember, this was also awarded the Nobel Prize in Chemistry in 2024. Uh, so compound generation, it boosts the efficiency and rapid identification of new molecular formulations. So these are the various ways in which GenAI is impacting drug discovery and development. And then we have this personalized medicine. So GenAI is not just revolutionizing the diagnosis process, it's also transforming the treatment plans. You can see some of the very interesting and recent articles within personalized medicines. So how it is being used for creating or developing the personalized plans for patients. Uh, GenAI takes the patient's unique genetic makeup, their health history, their lifestyle, and then creates the customized individual plans for the patients. So basically, they would analyze the extensive patient data to identify individual health factors like genetics, lifestyle choices, environmental conditions, and then informs the personalizations of treatment approaches. Um so this is to summarize in a more generic way how it is impacting the personalized medicine. So as every patient is unique, these personalized treatment plans can significantly improve health outcomes. These GenAI analyze the patient's medical history and other parameters and ensures that the patients receive the most effective treatment based on their individual characteristics. So we don't have this one plan fit all. Every patient has its own uh, treatment plan depending on their own individual characteristics. Um, for example, in the management of chronic disease like diabetes, GenAI can predict the likelihood of complications like diabetic retinopathy or neuropathy. By identifying the high risk patient, healthcare providers, that is the doctors, can implement preventive measures or closely monitor their conditions. Another example, GenAI can assist oncologists in developing personalized cancer treatment plans. By analyzing the genomic data and treatment outcomes from similar cases, GenAI can suggest targeted therapies that are most likely to be effective for a specific patient. So we have lots of examples in this. I would also like to talk about how GenAI is playing a significant role uh, in advancing personalized medicines like improving data analysis and prediction. So they have the capability of analyzing large amount of multimodal and multidimensional clinical and administrative data. So it's not just the genetic information, it's also the electronic health records, their previous records, the socio-economic determinants of health. So this GenAI helps supporting understanding the unique attributes of individuals and predict and infer possible health outcomes. Then we have another use case where GenAI is being used as clinical trials. So GenAI has the potential to greatly streamline and accelerate clinical trials through automation of repetitive tasks, advancing data analytics and predictive modeling. So as you would know that clinical trials are extremely complex, lengthy, and very expensive undertakings. These trials typically take several years to complete and involves extensive paperwork, uh, complex coordination, participant recruitment, and massive amounts of data collection and analysis, which results in delayed access to potentially life-saving treatments for patients. So GenAI has emerged here as a pivotal technology in realm of clinical trials, which reduces the long duration of clinical trials. By leveraging sophisticated deep learning and machine learning techniques, GenAI optimizes these critical processes, which leads to increased efficiency, reduced timeframes, and cost savings in the conduct of clinical trials. So anyone who is interested to read more about it, you can just Google these articles wherein people have talked about how it is being used to accelerate the clinical trials. So to sum up the clinical trials use case, so GenAI can rapidly generate draft proposals by analyzing historical trial data, automating document generation, enabling real-time trial adjustments based on emerging data. So these capabilities, GenAI capabilities, are cutting down planning time from days to minutes for many trial tasks. Another advantage, another industry that is reaping benefits of GenAI is healthcare operations. So hospital operations involve complex processes like patient scheduling, resource allocation, inventory management, staff coordination. How Gen AI is helping here? It analyzes the vast amount of data to identify patterns and generate insights that help streamline these processes. Efficient patient scheduling is very important to minimize the wait times. So this technology analyzes the historical patient data, appointment patterns, staff availability to create the optimized schedule. So by predicting the patient flow and demand, hospitals can allocate resources more effectively, ensuring that patients receive timely care. So for example, AI-powered scheduling system can predict the peak times for specific departments like radiology or surgery and adjust the schedule accordingly. So this not only improves the patient satisfaction, but it overall reduces the burden on the healthcare providers. Um, and of course, hospitals that are trying to continuously balance the allocation of resources like medical equipments, beds, nurses. Gen AI can help hospitals predict future resource needs based on historical data and current trends. If you remember, during the COVID-19 pandemic, many hospitals faced unprecedented demand for intensive care unit beds and ventilators. So, Gen AI models could analyze data on infection rates, patients' demographics, and treatment outcomes to forecast the ICU capacity requirements and optimize resource distribution. So GenAI is all set to transform the healthcare operations, um, to enhance the medical administration process, healthcare delivery by streamlining the schedules and resource allocations, patient management. Another area wherein Gen AI is very extensively used is virtual assistants and chatbots. So these virtual assistants are available around the clock to provide communication services, offering advice, answering questions, guiding patients through their healthcare journey. So these chatbots use NLP, natural language processing, to assess the symptoms, suggest the steps, and even notify their doctor in some cases. So the overall interaction improves the access to care and optimize healthcare resources. So here I would like to talk about the World Health Organization's new tool, the Smart AI Resource Assistant for Health. or Sarah. Uh, This AI powered chatbot offers health related advice in 8 languages, covering subjects such as healthy eating, mental health, cancer, heart disease, and diabetes. So, there are a lot many things that are being done in this domain of virtual assistants and chatbots. So, when the questions are more complicated or unusual, this chatbot may provide insufficient or incorrect answers. There is a long way before we can have a chatbot that is very accurate, like as an expert doctor. Uh, but this is a very, very important domain wherein researchers who are into natural language processing can explore further to see how they can create chatbots within the healthcare by using Gen AI. So Gen AI is of course helpful for medical chatbots because of its ability to extract and analyze large amounts of data to provide more personalized responses to patient inquiries quickly. Uh, So they can enhance the patient's education by creating personalized health education materials, like they can give answers to their questions. Depending on the skill set of the patient, they can tone down the difficult terminology that is being used in the report. Uh, so all the education material for the patient, it can be tailored to individual patient's condition, treatment plans. Um, uh, so this development of virtual assistants and chatbot is transforming the landscape of healthcare beyond diagnostic and treatment by significantly enhancing communication between patients and providers. Another very important area where GenAI is being used, this technology shows potential in planning and simulations by offering surgeons 3D models to practice and plan before actually carrying out the procedures. So this GenAI technology uh, creates the medical simulations that provides the doctors with efficient setting to practice and enhance their skills, which gives them invaluable hands-on experience without dealing directly with real patients. This enhances the quality of care and accelerates the learning process for medical practitioners. Um, so here I would like to talk about one very interesting um, uh, case. Like it's a Western Michigan University, and they offered 100 plus hours of AI powered simulation training in its curriculum. And this is, to my knowledge, this is the only university which uses uh, these many hours of AI powered simulation in their studies. So simulation offers an artificial but sufficiently realistic representation of a person, situation, event, or environment, which can be very useful in the healthcare industry because it's a very important tool for AI generated training modules. To sum up, so Gen AI is revolutionizing healthcare by introducing innovative solutions across domains, from personalized treatments to individual patient needs, AI powered clinical decision support systems that ensures accurate and timely diagnosis, 24 by 7 patient assistant through chatbots, drug discoveries. So GenAI is truly shaping the future of healthcare, making it much more efficient, accessible, and patient centric. All this while reducing the healthcare costs. Now, having discussed the various transformative use cases wherein GenAI is being used, I also want to detail the barriers to the implementation and usage of GenAI in healthcare and discuss why these challenges are important for ethical deployment. So, of course, as you know, that GenAI can be a game changer for healthcare. But like with any other innovative technology, it also comes with its share of risks and challenges. So, overcoming these challenges is very essential to unlock its full potential. So, what are the challenges? The first and the foremost challenge that I want to discuss with you is about the data privacy. So, data privacy and informed consent are very important when it comes to the use of Gen AI in healthcare. The capacity of Gen AI to create synthetic medical data and augmenting existing data sets, of course, presents new opportunities, but it also carries significant risk to patients' privacy because these systems are trained on substantial quantities of sensitive patient data. To mitigate this risk, it is crucial to implement robust data security measures, anonymizing patients' data, adopting strict access controls can help safeguard patients' privacy. Regulations like HIPAA, Health Insurance Portability and Accountability, is important for maintaining patients' trust and confidentiality. Another risk is algorithmic bias. AI models are trained on existing medical data, which may contain biases and disparities that could be because of the AI systems that are being used. If we don't detect these disparities and biases in our data, this can lead to unequal treatment and biased outcome in healthcare decision making. So here I would like to give you one example how this imbalanced data affects AI performance. This is in the prediction of melanoma from skin images. Now, the studies have shown that the darker skinned patients are often diagnosed at later stages of melanoma and have lower survival rates compared to fair skinned patients. And why is that? Um, Early diagnosis, as you know, is very important for effective treatment. But it so happens that most of the AI models are trained on the data sets that mostly include images from light skinned individuals from regions like US, Europe, and Australia. Now, this imbalance leads to poor performance when analyzing lesions on darker skin tones, resulting in less accurate predictions in real world settings. So, while melanoma is more common in fair skinned individuals, but this doesn't mean that, but that actually doesn't justify excluding darker skinned patients from the benefits of AI based detection. So, addressing this bias is very, very important to ensure equitable healthcare for all. What could be the mitigation strategy? It is very important to employ rigorous data pre processing techniques to identify and remove bias from training data. Involving diverse stakeholders, subject matter experts in the development and validation can help identify and mitigate biases effectively. So, for all the use cases or the challenges that I'm discussing, I have included the commonly read articles or the new recent developments in these areas. Um, you can you can take a picture or you can make a note, and you can, if you're interested in a particular study, you can just read that whenever in your leisure time. Gen AI, another risk is the hallucination that each one of you might have experienced while using ChatGPT. So while Gen AI can create realistic and convincing content, but talking about using Gen AI to create medical images, reports, or diagnostic recommendations, the authenticity and reliability of such AI generated content can create ethical concerns. And how to handle this? To mitigate the risk, clear guidelines and standards should be established for the use of AI generated content in healthcare. Healthcare professionals should be trained to critically evaluate and validate AI generated outputs before making decisions based on them. It is important to maintain hope. It is always important to have this human oversight and accountability in the use of GenAI to ensure that it complements and enhances the doctors or the clinical expertise rather than replacing it. Then another challenge is the regulatory frameworks. So currently we have a very fragmented nature of emerging regulatory landscape. So we have regulations from EU medical device regulations, GDPR, EU AI Act, US Health Insurance Portability and Accountability, which is HIPAA, FDA. So there are so many emerging new rules every now and then. So which creates complications for having one standard of usage of GenAI in healthcare. So the regulations pertaining to AI is still new. It's still developing. As of now, it is scarce. But through a combination of data, technology, innovation, and health, the baseline regulatory framework for AI in health is already in place. Of course, the future work will be about exploring specific regulatory challenges, especially with respect to AI medical devices, data protection, and patients' trust. So, for now, it is quite complicated. There are so many regulations that are within this AI and healthcare domain. And a lot needs to be done before we have one standard agreement of the usage of AI in healthcare. So it's a long journey ahead. And then we have another issue of interpretability. As you know that the black box problem makes it difficult to understand how AI arrived at its decision. So if we are using Gen AI to generate reports for some medical video or data or image, image or medical video, we would like to know how how did the model arrive to a particular conclusion. We would like to know. We would like to have some explanations. Uh, so the lack of interpretability in AI models is another obstacle to their widespread adoption in healthcare domain. So XAI, which is explainability AI. So there is a lot of development going on in that domain for now. So that is one answer of how we can handle the black box. So these XAI models are various methods that helps to have an explanation for the results that are being generated by the AI models. And then another issue in Gen AI within healthcare is the data availability and quality. Whenever we have to implement Gen AI applications in healthcare, the importance of data quality and security needs to be instantiated. We need to have these models needs to have fed high quality data. If there are any issues with the data quality, if it is left unaddressed, it can deteriorate over time, leading to compromised results. And healthcare data, the data is coming from multiple sources, different formats, and also we have limited access to comprehensive data sets, which further complicates the training process for these Gen AI models. Another is, of course, when we talk about AI, we have to talk about ethical issues. Uh, Gen AI technologies have the potential to improve healthcare. There is no doubt about it. But only if those who develop, regulate, and use these technologies identify and fully account for the associated risk. So if there is some misdiagnosis, whether it is the doctor who is to be held responsible for using that AI technology, or is it the developer, or is it the hospital system, or is it the insurance company? Somebody needs to be held accountable for it. Another issue is that, of course, there is a shortage of healthcare professionals which are proficient in AI tools. There are few doctors that are trained in data analysis or development of specialized models. So any student, if we have any student in the audience, then probably this is one area that you can try explore more. Uh, so for Gen AI to be effectively utilized in healthcare settings, it is very important to train and upskill healthcare staff, and which would include learning them to supervise AI models, integrating these tools seamlessly into their daily routines, realistic training simulations. So there are so many ways in which the healthcare personnel needs to be trained in using these AI tools. And then there are integration challenges. Most of the healthcare facilities currently operate on systems which are not compatible with advanced AI technology. And this kind of the discrepancy can cause disruptions in the existing healthcare workflows within their conventional settings. And integration of a new technology might face, the system might face resistance from physicians, as new technology could potentially alter their established practices. They might be required to change the way they operate. So, of course, there are integration challenges there. And of course, there is a misuse risk as well. AI generated outputs could include fabricated prescriptions, inaccurate summaries, um, harmful medical recommendations, or misleading the patient's information. So we need to have strict regulations in place to reduce the spread of misinformations, and developers should be held accountable for underestimating the potential of malicious actors that can misuse the products. So more of transparency. We need to have regulations that safeguards the technological innovations, safety standards, and a clear communication policies should be developed and reinforced. And of course, there is also a problem of patient trust. Um, so as AI continues to advance across industries, if you're talking about healthcare, patients are not very open to embrace AI-driven tools yet. So they might be skeptical of AI-generated advice due to concerns about accuracy and data misuse. So we need to have some ways wherein we can build the patient trust in Gen AI tools, so as to harness the full potential of Gen AI. So education of patients, transparency, these are the keys to build trust in these systems. To sum up, Gen AI holds tremendous potential to revolutionize the healthcare. But as just discussed, its adoption faces significant challenges. To address all these challenges that I just discussed, rigorous validation processes are needed to ensure accuracy and safety. Ethical frameworks and collaboration among stakeholders are very, very important for responsible deployment. So, having discussed the various use cases and the adoption challenges, I want to ask you a question. Do you think that our family doctor would be soon an advanced AI chatbot? Or will we still follow the today's internet user who try to diagnose themselves like Google Doctor? So we really don't know how this AI, Gen AI will develop in healthcare. But it is very important to understand and acknowledge that this technology is here. It's going to stay here, and it is already changing the medicine right before our eyes. So I will try to illustrate how patients' journey in hospital will evolve with the integration of Gen AI. So I'll compare the traditional approach to modern AI-driven methods, highlighting the improvements in efficiency, accuracy, and overall patient's experience. So number one, patients arrive. Now, traditionally, patient would arrive at the hospital, had to register manually at the front desk, often facing long queues and filling out numerous forms. With Gen AI, patients receive personalized instruction via SMS or email and would use self-service kiosks or mobile check-ins for a seamless registration process. Patients check in. During traditional check ins, patients are escorted to waiting rooms and they might face delays due to manual processes like paperwork. But talking about Gen AI powered chatbots would streamline this process by collecting the patient's information efficiently. They would be having the access to their previous records, their electronic health records to reduce the time, to reduce the errors and save time. And of course, these systems can also provide preliminary medical assessments, which would streamline the whole check in process. Talking about diagnosis and treatment. In traditional diagnosis method, doctors would rely on physical examinations and manual data analysis. With Gen AI powered tools in place, we can analyze medical data, medical images, we can predict disease progression and suggest treatment options more accurately. And of course, with Gen AI chatbots or virtual assistants, we can have more clear communication of personalized treatment plans to the patients. Talking about discharge and follow ups. In traditional settings, it would involve multiple conversations and paper forms for instructions and follow ups. But AI simplifies this by sending personalized discharge summaries and medication reminders directly to patients' smartphones while scheduling up follow up appointments automatically. So, AI offers numerous benefits across patient journey, improved efficiency and accuracy, reduced wait times through streamlined check-ins, enhanced diagnosis with data-driven insights, optimized treatment plans tailored to their individual needs, and automated follow-ups for the better post-visit care. So as the patient can go back to his life with renewed health, doctors can be relieved of the paperwork. They can put their expertise to use in patient care. So, this is just the beginning of a future where technology and compassion work hand in hand to improve lives worldwide. So, I would like to give you a small demonstration. Yeah, I have some time. I would like to give you a small demonstration on Vertex AI, which is a powerful machine learning platform to enhance the healthcare applications with both predictive and generative AI capabilities. In this demonstration, you will see the capabilities of generative AI models like Gemini. I'll show you small experimentation with the prompt design to summarize the text, answer questions, classify sentiments. All can be done with the Cloud Console. Um, while I set up my lab, I want each one of you to please go to this and give your feedback. It will just take you 1 minute of time. And while you fill the feedback, I will quickly set up my lab. Is that okay? Yeah, is it okay?
Yes, ma'am. Okay. Ma'am, Mentimeter is asking to sign up.
Okay, just give me a second. Just try now.
Okay, ma'am.
Is it working now?
Yes, ma'am.
Yes, ma'am.
Okay, thank you.
Ma'am, okay, okay, received.
So are we done with the feedback? Or you
Yes,
need
ma'am.
some more?
I think most of the people have completed.
All right. Okay. Thank you very much for your time to fill out the feedback form. I will just take, is it okay if I invest some 5-7 minutes to
Yes,
show a
ma'am.
small
Yes, ma'am. Sure,
demonstration?
sure, sure.
Okay. Yeah. So I will now share my Vertex AI Studio to give you a small demonstration of how Gen AI is being used for summarizing the medical images, videos. Um, is my Vertex AI visible to everyone?
Yes, ma'am. Visible.
Okay, so this is the Vertex AI Studio wherein this different Gemini models are integrated. So I'll quickly show you how it is being used for being used for the healthcare professionals. So if you see the console, we have the configuration on the right side. Here I can select the different Gemini model. So for my usage, I will be using today Gemini 1.5 Pro. And this is the temperature which indicates the randomness in the output that will be generated. So, so if you see, it basically controls the randomness in token selection. So a lower temperature, that means towards zero, is good when you expect a true or correct response. So a temperature of zero means the highest probability. So for this to understand the token and everything, you should be aware of how Gen AI is working by tokenizing. So a temperature of zero means the highest probability token is usually selected. But if you select the higher temperature, that can lead to diverse or unexpected results. So for my task, I will, let's say, set to zero, and this is the output token limit. What is this? This determines the maximum amount of text output for one prompt. So one token is approximately 4 characters. So what I will do is I will now insert my image and I will ask some questions. I will say, um, image, and then I will say, give a short summary of this. So I already had downloaded this image, saved it onto my folder, and now I'm re-uploading it here for Gemini to give me some outputs. Give a short summary for this image. And another question is, okay. So my first question was that I wanted to have a short title for which very aptly it says right lung tumor X-ray. So of course we see some abnormalities in the right lung, and it gives me some summary. This image shows an X-ray of a chest with a tumor in the right lung. The tumor is depicted as reddish mass within the lighter lung tissue, the skeletal structure. Of course, I'm not an expert. I'm just here to demonstrate. I don't have medical information and knowledge, but I just want to showcase of how it is giving the summary. And then when I'm asking what is the diagnosis, it is of course giving me some diagnosis. It suggests a possible lung tumor, and it comes with a disclaimer that it is just an illustration and cannot be used for actual medical diagnosis. So there is a possibility of using Gen AI to give some analysis, some diagnosis, But of course, there is a long, long way before we can have a trust on the Gen AI generated results. Also, I would like to show you another small, okay. I'll again set my Gemini model, and I want to show you so if you see, this is a short video that I've uploaded, and it's an animation. And I would now want to know about and I want to know okay, so let's try out this one. So see, this can take static images. Also, it can analyze the videos. So the response is that this short video shows 3D model of a human torso that highlights the ribs and lung cage, lungs and rib cage. The lungs are shown in the orange red tone and so on and so forth. So it gives that. And also, I'll just show you. If this can also be used to check the sentiment of the text. Um, so this is hypothetical cases that I'm putting. Okay. So let's try out for these two. And it correctly classifies the text into different sentiments. Also, it gives you the possibility of showcasing, of doing, if you know, zero shot learning, one shot learning, and few shot learning. So in zero shot learning, you don't provide any examples. One shot learning is you provide one example and you want it to generate similar to the example that you have given. And few shot is you provide some samples on the basis of which it will give you some similar answers, similar looking answers. So it gives you that possibility. You can just add the input or the output that you would want to give the model to learn, basis which it will customize its output. So I just want to show that we have a facility here. I think I am already 4 minutes up, so I'll just quickly close this. And thank you very, very much for, I just would check if I have, okay. Yeah.
Yes, ma'am. Thank you so much, ma'am. Ma'am, you want to
Yes.
show something?
Yeah, I was just looking at whether I have the feedback. If you want me to share the
Yes.
feed, do you want me to show the feed? But I think some people have actually filled it. I was just looking at the feedback.
Yes,
If
ma'am.
I have this or not.
Participants, please complete the feedback.
Yeah, yes.
Sunita, ma'am. Yes, Sunita ma'am, you want to ask something? Please unmute yourself for the same. Sunita ma'am, you can unmute and ask the queries. I think she's not here. Okay, thank you so much, ma'am, for such an informative and interactive session. Your
I hope it
expertise
is a
has
not a,
truly.
I hope that I have been able to address some of
Yes,
the queries of the audience, and I hope you're not giving me a generic feedback, because I see that everybody say, yeah, it was informative, but I'm hoping so that the effort that I made
it
was
was
useful.
actually very informative, ma'am, very interactive also.
Okay. Yeah.
Okay, thank you so much, ma'am. Thank you so much for
Okay.
such a great session.
Yeah. Thank you
Okay,
very much.
thank you.
Okay. Bye.
Any participant, if you want to ask something? Sunita ma'am, you can unmute and you can ask. The content will be provided to the participants. Thank you. Okay, ma'am, I think no queries are there from the participant side.
Okay.
Okay.
All right. Thank you very, very much for a nice audience. You were very patient in listening to what I was saying. So thank you very much. And in case if you have some doubts or you would like to connect sometime in future, you can just you can, of course, you can connect me on LinkedIn, and we can talk there.
Okay. Thank you so
Okay.
much.
Thank you, ma'am.
Bye. Thank you, ma'am.
Okay.
So this was the end of session 2 of day 3. We will have the next session, session 3 for day 3 on at 2 p.m. by Dr. Neeraj Kumar. So we will join at 2 p.m. Till then, you can enjoy your lunch. Thank you so much. Please connect at 2 p.m. sharp.